I'm going to do something, okay, which will not affect your life too much. So what I'm going to, really? Okay, so what I'm going to do is I'm going to wipe this off. Okay. The reason why I'm doing this, because I want you to see something that only you can see if I do this, okay? I know it sounds weird, but we will get there. I'm going to change this now to a rotation. Now it is what? Now it is in anti-clockwise, 30 degrees. Okay. But I'm also still going to call this Y what? Y30 line. Okay. I'm still going to call this. So I'm going to call this can you change the question to counterclockwise? Okay. From the horizontal plane. Are we clear? Right. So this thing is going to rotate 30 degrees counterclockwise rotation from point what? From point Y. I highlight again that this is from point what? Point Y. Okay. A lot of times students go to Mohs circle, they go and say, oh, it's from the horizontal axis. No, it's going to be from point what? Y. So from point Y, we know that this angle of rotation on the element will be how many degrees? On Mohs circle will be how many degrees? 60 degrees. Well done. You'll remember. So I'm going to sketch 60 degrees over here. Okay, I'm going to do a proper eyeball. Okay, so this is 60 degrees. 60 degrees from point what? So we know that this is how many degrees? Oh, it looks chaotic now. Okay, so this is this angle over here. Right, this angle over here is what? 60 degrees. The rotation direction has to be the same. This being what? Anti-clockwise. This also have to be what? Anti-clockwise. On the element is 30 degrees. On Mohs circle is what? 60 degrees. Yes. Hey? Later. No, this has nothing to do with principal plane. Okay. Right. So now the next thing we have to find is we have to find this angle over here. And this angle over here that we need to find is known as our what? Beta angle. Okay. We have to determine our beta angle. Okay. Before we can determine our beta angle, there's an angle that we have to determine first. And this angle over here, which I drew in green, is known as 2 theta p. We have to determine our 2 theta p first. Okay. So therefore, tangent 2 theta p will be equal to what? Will be equal to 20 divided by 30. And 2 theta p will be equal to 20 divided by 30. Inverse tangent is equal to 33.69 degrees. Or 33.7 degrees. So from here, we can determine our beta angle. So therefore, our beta angle will be equal to 60 degrees minus by 33.7 degrees. So 60 minus 33.7 is equal to 26.3 degrees. Okay. At the end of the day, what we are trying to determine is we are trying to determine at this point, okay, we are trying to determine at this point a coordinate system, which is our normal stress 30 and our shear stress 30. Then we also want to determine what is on the other point, which is our normal stress x30 and our normal stress y, our shear stress y30. This is what we are trying to determine, okay? So now we have the angles, we have the beta angle, and then we have 26. We also know our geometry in terms of our length. So now I'm going to expand this view over here. Okay, I'm going to expand this view. I'm going to take this out. Okay, where I've just highlighted. And then so this is our stress. We call it our stress 2. We found our center of circle somewhere around here, and this value happened to be 70 and 0. And then there's an angle that we work up to is 26.3. So 26.3 is about this angle over here. Okay, and this is the point that we want to identify. This is our stress 30 and our y30. And we know that this is a circle. Okay, so what we know over here is we are aware that over here, this angle over here is what? This angle over here is equal to 26.3 degrees. So we want to determine what is this point, our stress 30, our shear 30, okay? We know the radius. The radius is equal to what? 36.05. So that's a good thing, okay? Listen to what I focus on what I'm doing now. Why? Because this will help you reduce the possibility of creating an error. Let me elaborate. Okay. So the first thing that you have to do is you are going to determine shear 30. Okay. So shear 30 is equal to what? 36.05. Sine or cosine, anyone? Sine 26.3 degrees. Am I right? Right. So sine 26.3 times by 36.05 is equal to 15.97, 15.973 megapascal. Okay. So we know that our shear y30 is also equal to our shear x what? 30. They are the same magnitude wise. Okay. So from here, we are going to look for our what? Normal stress what? 30. Okay. So why this will reduce your possibility of mistake? Okay, and I'll show you why. But before we go there, we need to put in our 70 first. Okay, and then minus 36.05 cos 26.3. Okay. Why I encourage you to do your shear first is because you already use what? Sine already, yes or no? When you do your normal stress 30, there's more stuff for you to think, right? So it's best you know that the shear is 30, the normal has to be what? Cos. So you won't make any more what? Mistake. Are we clear? Okay, I've been teaching this 13 times now. Very common mistake. Okay. Now, why the normal stress is different than the shear? Okay. If you look at the origin, this is the normal stress and this is the what? The shear stress. The shear stress starts from what? 0. Are we clear? So you don't need to plus or minus. The normal stress starts from what? 70. And the fact that it's going to be on the left-hand side, what must you do? Just put a minus sign. Clear? Okay, so that's why we do that. So from here, you have 70 minus by cos 26.3 times by 36.05 is equal to 32.318. Let me do it again. 26.05 times by cos 26.3. 32.318. So 70 minus 32.318 is equal to 37.682. From that, you can calculate your stress Y30 is going to be 70 plus by what? 32.318. So 70 plus by 32.318 is equal to 102.318 megapascal. Okay. So we have our values now. Okay. Right. So the next thing, even as important or more critical, how to bring it back to what? How to bring it back to real life. Okay. Remember, most circuits are calculator, right? We have to bring it back to real life. Okay. So bear with me. I'm going to copy this diagram. I'm going to paste it here. And I'm going to make it big. Okay. So you can see better. I do apologize. I make it too small here. Okay. What I'm going to do is I'm going to get these values also. Okay. And I'm going to paste these values over here. Now, next we are going to bring it back to the what? To the real world. Yes. You're right. Thank you. 1 pint. Okay. You're absolutely right. Thank you. If I can get into here to erase this. Okay. You get your pint on your last week of term. Are we clear? I know 2Q also owe you guys a lot of alcohol. Just let me know. Okay. I know I made a lot of mistakes. Okay. I also will buy some orange juice for my friends that don't drink. Right. So now the critical part is this. We have to bring it back to the what? To the real world. Okay. So how to bring back to the real world. Remember on Wednesday, I told you how to do what? How to bring it back into the element without the shear. Remember? Right? Because it's at its principal plane. This time it is different. What is the difference? Okay. So now we draw our original axis. So this is our 0. And the vertical is also our 0. Okay. So we know the element has been rotated what? 30 degrees from the horizontal. So I'm going to sketch 30 degrees clockwise from the, anti-clockwise from the horizontal. So this is about 30 degrees anti-clockwise. Okay. Then I will rotate this by 90 degrees. Then we are going to put our element in here. Okay. Then from here, I would like you all to sketch where is your Y30. So sorry, this is your point Y. And this is your what? Point what? Point X. Point 30. Yeah, Eugene, come on. This is your point X. Okay. So now we know that Y, so this is this point over here is our what? It's our Y30. Yes or no? So from here, going to our this point over here, this point, can you also label this point? In fact, is our Y30 point, right? And this is our, this point over here is also our X